Good morning, everyone. So today we are going to see some of the different types of energy. Generally, last time we have seen about the energy, that the ability to do a work is energy, and the unit of that energy is joule. That we have seen. Not only that, last time we have seen that there is different types of energies are present, like electric energy or a muscular energy, or a wind energy, solar energy, heat energy, and something like that. But in the base of all of the energy, there is mainly two types of energy. The first one is the kinetic energy, and the second one is the potential energy. So today we are going to see about the kinetic energy and the potential energy. First of all, our first topic is the kinetic energy. What is the kinetic energy? The kinetic energy is the energy which is possessed by an object due to the motion of that object. When object is in motion, due to its motion there is some energy is possessed by that object. As you know that if we are using two different things, like both the things has the same mass and the same shape, but after that the higher energy possessed by the object which is in a higher motion. Like whenever you are using a bullet, right, as a throw, and sometimes when you are using that bullet fired from the gun, then you know that the energy in the bullet which is fired from the gun is higher because its moment or speed is higher. So due to that speed, generally every object possesses energy. And this energy is known as kinetic energy. So the kinetic energy is the energy due to the motion of an object. Understand? So that is known as kinetic energy. Now we have to derive the equation for it. For that we have to just assume that one object is steady or stationary, steady on frictionless surface. Let one object is steady on a frictionless surface. Suddenly, F is applied due to acceleration A is produced. The acceleration A is produced and it covers S distance in time t and reaches velocity v. That one object is just steady on a frictionless surface, so its initial velocity is 0. But as the force is applied on it, it starts running or it is in motion, at where the acceleration A is produced, and due to that it reaches to the v velocity and covers a distance s. So the work done is W, which is force into displacement, right? According to second law of motion, what is the equation? That the F is equal to ma. If we are thinking that this is the equation number 1, equation number 2, then by putting equation 2 in equation 1, what you get? You get W is equal to MAS. Equation number 3. Now, that object is moving with the constant acceleration A. So we can use a constant acceleration motions equation. So from the equation of constant acceleration, the 2as is equal to v square minus u square. Now in this equation you can see it here as, right? So just remove that as. For that you have to make it here as. So as is equal to v square minus u square divided by 2. Equation number 4. Now put the value of 4 in equation 3, right? By putting equation 4 in equation 3. The equation 3 is w equals to mas. So the in v square minus u square by 2. So just put this 1/2 in outside and you get w is equal to 1/2 m. 1/2 m. In bracket v square minus u square. But as we know that u is 0, so w equals to 1/2 m v square minus 0 square, because initially the object is in a steady position. So the w is equal to 1/2 mv square. Right? Here it is the work. As we know that in our previous lecture where I have said that the work, it means to give and take a energy. So whenever you do a work, it means a significant amount of energy is just given to someone or taken by someone. If you are doing work, you are giving some of the amount of energy to the other object on which you are doing a work. So the total work is the energy which is given by someone. So you can say that this work is converted into energy. So whenever you are doing a work, some of the energy is converted, right? That work is one of the energy. So you can say that if we are thinking that, so the W is equal to take as a EK. Sorry, it's a kinetic energy. So it's a EK. So the EK is equal to 1/2 mv square. Here it is the equation of kinetic energy. What is the kinetic energy? The kinetic energy is the energy possessed by an object due to its motion. Is known as kinetic energy, right? And if we are thinking that the one object is in a steady position, and after applying some of the force, it covers a distance s at a constant acceleration a, and which is to the velocity v. For that you can say that there is some work is done on it. So the work done is W equals to F into S. Right? According to the second law of motion, F is equal to 1. Put the value of it and you get W is equal to MS. As you know that we need EK is equal to 1/2 mv square, in which the M is there, but there is no AS. So we have to remove AS, and for that we are using the equation of constant acceleration, in which the 2AS is equal to v square minus u square. So you get AS is equal to v square minus u square by 2. Now put the value of AS in the equation 3 and you get this equation. But the u is 0, so put the 0, then you get W equals to 1/2 mv square. But as you know that always work is converted into energy. And at here, this work is converted as a kinetic energy because we are doing the work to produce a motion. So it is converted into kinetic energy, which is given by EK. So put the value of W as a EK, then you get EK equals to 1/2 mv square. It is the equation for kinetic energy. It can be asked you in your exam for a 3 marks. So it is one of the most important topic for us, because it can be asked you in your exam. That question can be like that: what is the kinetic energy? Derive the equation of kinetic energy as EK is equal to 1/2 mv square. So here it is the equation, the derivation of equation of a kinetic energy. Just see it for 2 to 3 minutes. kinetic energy. Like that, one another energy is known as the potential energy. It's a potential energy. What is the potential energy? As the kinetic energy is due to the motion of an object, like that the potential energy is due to the construction of an object, or sometimes it is due to the position of an object. Generally, in this chapter we are going to see about the position of an object, not due to the construction of that object, right? Due to construction also, it has some of the energy stored in it, but due to the position also it has some energy. Like just think that whenever the object is just put it from some height, right? Due to this, some of the dent is created on the surface on which it just strikes after when you leave it from some height. But if the height is more, as the height increases, the effect due to the striking on the ground is more. It means whenever it strikes to the ground, it uses more energy to produce the effect of it. That means that when the height is increases, the energy stored in that object is also increases. And whenever it reaches to the ground, it uses that energy or decreases that energy on the other object, due to which there is a effect is produced on that surface. Understand? So we can say that due to the position or from the height of earth, that the object possesses some of the energy, and this energy is known as the potential energy due to the height of an object. But as a potential energy, whenever you want to define it, during that time you have to use a words like that the object position energy due to the position of an object or the construction of an object, then it is known as the potential energy. Because the potential energy are of a different type, it can be a different type of position, right? But whenever we are thinking about the height, we can say that it is a gravitational potential energy, because at here the object is in opposite to the gravity, and due to the gravity it just comes in the surface or towards the ground. So it uses that energy. Whenever it wants to remain on the height, it always tries to oppose the force of gravity. Gravity is always tries to pull it down. So it needs to be go there. But in the opposition of it, it always use a opposite force. So every time this force is stored in it, and it gives it energy. So whenever it just goes in a downward direction, this energy is used at here. As the energy decreases, because it does not need to produce a force opposite to the gravitational force, and this energy becomes zero on the ground, and this energy is converted in some another manner by producing an effect on ground. So it is known as the potential energy. This is also one of the most important topic, as it can be also asked you in your exam for the 3 marks, that what is the potential energy and derive the equation for the potential energy. So you have to derive the equation for potential energy as same as the kinetic energy. So first of all, we are going to derive it. But first of all, what is the potential energy? That I have said you, the potential energy is the energy possessed by an object due to its position or a construction, which is known as the potential energy. Now we are going to derive the equation. At here, there is one figure in which we can say that there is one object is on ground, right? As the object is on ground, the height is 0. The height is 0. Now we are applying a force to take at some height. As you know that if you want to take any object on some height, you have to apply a force. Without applying a force, you can't put it on some height. So you are applying a force F. And you just reach at the height S is equal to h. This distance is h. This distance is h from the center of it. I am just taking from the center of an object. Right? This distance is h. So I am just taking that object at some height by applying a force. Right? Just assume that. Assume that one object is put it on the ground. So the distance h is equal to 0. By applying force F, I take it to some height h, due to which it displaced by distance s. The distance is s, at which it is the displacement by it, and the s is equal to h, right? So you can say that the s is equal to h, because that is the height at where we just put at the object, and it is the displacement done by the object. So the work done. So it is a work done. What is the work done? The work done is equal to W. W is equal to F into S. W is equal to F into S. Equation number 1. According to the second law of motion, according to second law of motion, F is equal to equation number 2. Now, at here, that the force MA, in which the acceleration is produced in an object which is opposite to the gravitational force, means that acceleration is the gravitational acceleration. Here, object is taken in opposite to gravity. Therefore, acceleration produced to move an object is due to gravity. So, acceleration is gravitational acceleration. So, A is equal to G. So, from equation 2, F is equal to mg. Put this value in equation 1. Put this value in equation 1. Then W is equal to mgs. But S is equal to h. So the W is equal to mgh. Here the work done by an object is converted as a energy. So work converted in energy. So the W is equal to EP for the potential energy. So EP is equal to mgh. Here it is the equation for the potential energy. Once again, I will just read it. So the potential energy is the energy possessed by an object due to its construction or the position. At here, the object is just put it on a ground, and by applying some of the force, I just put it and take it at some height, which is the h. So at here, the h is the s, which is the displacement done by that object. So now the work is done. So it is W equals to F into S. But as you know that the F is equal to ma. But at here the object is just put it at some height in an upward direction. It means there is a gravitational force is also applied on it, which is in downward direction. So we are just doing a opposite work to it. So the acceleration produced on it is due to the gravity, which is the g. Right? Which is the g. So we can say that A is equal to g. Put the value, then you get F is equal to mg. Now put this value, then the W equals to mgs. But as we know that the displacement is the height, so S is equal to h, and we get W equals to mgh. So at here the work converted in energy, so you get W equals to EP. So EP is equal to mgh. It is the equation of potential energy that we have to derive. It is also one of the most important topic for you because it can be asked you for 3 marks. Just watch it for 2 to 3 minutes. So here is the two main energy, right? The kinetic energy and the potential energy. What are most important topic for you, because one of them can be asked you for a 3 marks, and if the one of them asks you as a 3 marks, then the another one can be asked you as a 1 marks or a 2 marks, or sometimes the sum of these energies can be also asked you in your exam. And this is the base of this chapter, because in energy generally a main energy, the type of main energy is a kinetic energy or a potential energy. There is so many other types of energy are present, like muscular energy or a heat energy or electric energy or a wind energy, solar energy, and something like that. But all of them are either kinetic energy or a potential energy. Means the basis of the energies are the kinetic energy or potential energy. As the heat energy is one of the kinetic energy, that the electric energy is also one of the kinetic energy. The solar energy is one type of the potential energy due to the construction, right? So you can say that all these type of energies can be of a kinetic energy or a potential. It is the type of the kinetic or a potential energy. Or you can say that the kinetic energy or potential energy are the basis of a different types of energy. So it is the most important topic, not for only for your exam, but also if you want to think about energy, or if you want to learn more about the energy, then also that the kinetic energy and the potential energy are the most important things, and it can be asked you for a 3 marks in your exam. So according to the point of your exam, also these two theories are very important. And you have to also remember all the equations of these two energies. There is 2 equations for it. Like for a kinetic energy, it is a 1/2 mv square, and for the potential energy, it is a mgh. There is some sums related to it, and they can be used. These equations are used in these sums. But first of all, you have to just try to understand which type of energy that you have to find, or what you have to find. Then you can easily find out the energy, because there is no another equations. There is only 2 equations. The Ek equals to 1/2 mv square, and the another Ep is equal to mg. Only 2 equations are there, and which are very easy. It is not that much longer or hard to remember it. It is the easiest one. That the Ek 1/2 mv square, Ep mg. But the main thing is that what you have to find and where to use. It is the most important thing in this examples related to these two energy. So here it is the 2 main type of the energy. The another things which we can say that the different types of energy can be a kinetic or a potential, something like that. That we will see in the another lecture. Today we are just finishing our lecture at here. Understand?